Can you hear me? Can you hear me? Eric, you down there? Go for a second. Wait, no, okay, good. They can hear me. All right. All right. Excellent. All right. Welcome, everyone. My name is 14, 15 weeks. Talking about web development. That's correct. In the right group. Good. Yeah. So there's quite a bit of technologies development. We have HTML, TypeScript, tons of things. Databases, servers, clients, browsers. For this program, material that we're going to be covering this semester. And it is, I think it's written the course for anyone, even if you've never gone through web development. Doesn't assume that you know any prior knowledge of software and apply to web development. It does assume that you know a little bit of object-oriented programming, maybe some functional programming, some data structures, things like that. Networking basic. But I hope that the kind of material that works you from zero to hero. So you should all have access to the Canvas course, where you should have access to the syllabus. It is a fast-paced course, so I do ask that you do stay on top of it. Every week, 10 assignments, which we won't have assignments for spring break, the first exam, the final exam, and the project exam. But other than that, there's one assignment every week, and they mostly build on each other. So you have to just keep at it, to stay on top of it. But we do give plenty of office hours and add some work. So if you find yourself on time or you're a little bit frustrated with something work, please don't hesitate to get hold of yourself or the TAs. We're here to make this a success, right? So if things are taking a little bit too long to please for help. So yeah, let's see. So all these lectures will be recorded. So if you need to go over them, please, it's available from the Zoom meeting section on Canvas. So you don't have to take notes or please pay attention. And I do a lot of live coding. I don't expect you to follow along recording after me. And also we run into some bugs that we will fix here together. Some of them are deliberate, some of them are not. We'll just have fun fixing those as we go. But yeah, I don't expect you to be able to code right after me and try to fix things. Or sometimes I get questions, oh, I tried that, it's not working. Well, I can't do it. For everybody. So if you could just pay attention on this side. There are several evaluation strategies for this course. Certainly there's assignments, right? That's every week. There are quizzes that every other week. There's 2 exams, one of the midterm and one of the final. And there's a final project. Final project where a team of between one, either yourself or 4 other students, 5 people, to collaborate together to build something of your own, right? So the assignments are meant for for us to handhold you through building a project. right? We just show you, well, here are the steps how you build a web application, right? And everybody's building the same thing, right? And there are very strict guidelines of what to do and how things have to look like, how to behave. And we're also showing you some best practices, what to do, what not to do, how to organize your code and whatnot, right? And then the project is meant for you to go out and then apply everything you've learned, all the skills that you've learned, handholds for the assignments, and then go on and build something on your own, well, with other teammates, right? You get to decide what you build, and as long as keep it PG-13. Whereas the assignments are very rigid on what we ask you to build, right? The project, it's a little more open-ended, right? We use a specific stack, developer stack. We use React.js for front end, we use Node.js for middle tier, MongoDB for the database, and it's very rigid, mostly because we have to find a standard way of writing everybody. And so it's very hard to do their own thing. But for the project, you're welcome to explore other things. Right? You want to try Vue.js or Angular, or other front end framework. You're welcome to do that. If you for the middle tier, if you prefer trying out Python or C# or some other middle tier, again, you're welcome to explore other middle tiers. For other databases, if you prefer a relational database, MySQL or something else, or Firebase or whatnot. Again, the project is more open-ended. Feel free to explore there. There are things that are standard that everybody has to do, but it's more functional. We'll ask you to, everybody has to implement login, everybody has to implement a profile page, or be able to interact with the third-party API. So there are some standard things that everybody has all have to accomplish in the project, but we're not going to ask you for staff or right, so you're welcome over there. Right, so more of that as we go. Right, so this course will also be run in parallel with two other sections. They are graduate students. So we do go and explore some other things with the graduate folks. The assignments have a section that is particularly dedicated to the graduate students, right? So you're not required to work on those sections, those parts. You're welcome to, right? You can explore some more things if you want, but you're not required to, and we won't grade you over it. Okay, so if you want to explore it, that's fine. We do handhold you there as well. So if you want to do that, it's up to you if you want to do that. We also have office hours for each one of the sections. And so you can either on Canvas, there's links to join the office hours. And there's dedicated office hours for this section, and then office hours dedicated for the graduate students, right? But I'm going to welcome anybody joining any office hour. I'm just going to give priority to the students for that particular section, that particular office hour. And so I think the one scheduled for this section is tomorrow morning, right? And so if any other graduate student joins, I'll always ask that please have them wait a little after I've helped everybody from this section, right? Same thing. If you join a graduate student section of the tower, again, I'll help those folks first, right? But then at the end, I'll gladly will help everybody else as long as you're there. So just to manage expectations. The TAs are also going to have office hours. They haven't posted that yet. They'll be introducing themselves in Council later today or tomorrow, and they'll be posting their own office. Assignments are due on Sunday at midnight, so we're going to try coverage, office hours coverage also weekend, and perhaps a little less on Monday. And since you probably have submitted your assignment on Sunday, or you want to press Monday. But again, just keep at it, just keep an eye on it. Yeah, so there is a required text that's available for purchase online. Okay, so All right, these are the Zoom. I'm sorry, these are the Zoom meetings. If you want to join, this is the Zoom meeting that we're currently here right now. If you want to join the other graduate Zoom meetings, just to see any difference, we're going to try to keep it as close as possible. But I will go into some other details, other advanced topics. Right? So if you want to join and see most of the same content that we see today, plus more, you're welcome to join there as well. I believe they don't have any passwords. You should just be able to click and join if you want. One is tonight at 6, and then the other one is on Thursdays at 6 if you want to join. And then these are the office hours. They're all in the morning. Again, so let's see. Yeah, so today is mostly the course and getting you up to speed with the first assignment. Right, so the first assignment is going to walk you through setting up the development environment. Again, so we're going to be building all of your web application, and so we'll need to implement a front end, which will be running on the browser, using React.js from JavaScript, dynamically generating content on the front end. There will be built here a server that will be a Node.js server, and that will be providing a web services, RESTful web services for asking for data. So the client on the browser asking for data from the Node.js server, and then dynamically rendering that content on the browser. And then the database stack and Mongo. So this week we're going to set up the front end, right? And we're going to focus mostly on the front end for the first half of the semester. Right? So we're going to learn about HTML, some CSS, JavaScript, React.js, Redux, state on the front end side, and hosting this on a public front end service. We're going to be using Netlify, right? You're welcome to explore other options like AWS or other free options out there. But for the assignment, we're going to assume that we're going to stick to Netlify. That's where she has assumed that they're going to go there and grade you there. Also, all the slides, all the material, the assignments assume that you are deploying it. So we give you a lot of support if you follow the assignment. So today we're going to set up the environment this week, and that's the first assignment, and that won't be due till the 22nd. Okay? So this is one of the assignments that will give you quite a bit of time, and setting up environments are usually very painful. It's it works for me, but doesn't work for you. And some settings depending on the operating system that you're using, right? Some version differences, some data you got to install prior in other courses that are compatible with what we're asking you to install in our course. Right? And says, oh no, I installed MongoDB 2 semesters ago, right? Or installed Node.js 2 semesters ago, right? And so versions might differ, and so that's what makes it painful, right? Just the versioning and the compatibility. So that's why this particular assignment is have a little more time. Because notes is going to go up to me, and please ask us and come to the office hours and help do it. But just again, I want to manage expectations. Setting up environments is always the first painful part of this. You're getting it up to run, right? My hope is that 80% of everyone will get it up and running just as described in the assignment. But there'll be 10-20% of students that will have to just help them out that part, right? So hopefully everybody will be done later this week, but certainly there'll be something that we will need to help them with. So that's the first one. So next week, Monday will be the first of several Monday the holidays. Next Monday, so we're not meeting next Monday. We'll continue. We'll introduce HTML this week on Thursday probably, and we'll continue discussion later next week. We'll focus on HTML. HTML is the language that we create content, right? Create what. So for instance, this Google Doc behind the scenes is rendering. The browser is rendering HTML. It's the language browsers understand to say that, hey, this is a row, and the title up there, and all the buttons are over there, the blue button over there, and this title over here, even the tab, right? tab, the title of the tab, that's all described using HTML. Right? So we'll spend about a week and just to introduce HTML, although we'll be talking HTML all throughout the semester, right? But we'll introduce it only HTML on next, well, this Thursday probably, and continue on to next Thursday as well. So we'll introduce that. Then we'll do some more HTML the following week. On week 3, we'll do some more HTML, introduce additional tags. But then we'll focus on another language for styling web pages, right? It's what determines whether that button is blue and this row is yellow and border is gray, right? And then the font that we use, right? The size of the font, how much padding there is, margin, right? So we'll spend about a week there as well, and the own language. And we'll quickly learn that it's very hard to just by using raw CSS is very hard to make things look pretty. Look professional and whatnot. And so we will just learn the language just to know how it works, right? What's the syntax and what are the different properties that and the knobs that you can tweak. But we'll quickly abandon just raw CSS and instead use a library that collects all sorts of really nice, good-looking, professional style library or a CSS library. So it's CSS rules that is created by professionals that have been doing this for a while. That just apply CSS rules here and there, and you can make your. And so the first week we'll introduce what the syntax is and what is it and how it works. But then we'll now we know now that you know the multiplication table, the addition table. Well, here's the calculus. Right? So the first I'm just trying to understand what the concept is, and then here's how to do it professionally. Here's what professionals do out there. There's tons of libraries. We're going to do Bootstrap, but there's Python out there. But Bootstrap is a nice, easy way of easy learning curve, but they're all copying each other. There's a lot of competition on various CSS libraries out there, but Bootstrap, I think it's an easy one to get started. But you're welcome to explore other libraries. Tailwind is one in CSS by Storm, and certainly I would encourage you to try it out in your project. Right? Definitely that's an industry that's going forward to those kind of libraries, and you're welcome to explore those. But for the assignment, please stick to Bootstrap, right? But you're welcome to try out Tailwind, in your projects. All right. So up to this point, those first 3 weeks, it's going to be building static content, static HTML, making it look pretty, but it's static. Right? So whatever you code, that content is always going to be that. Right? It's not going to change over time. So we'll introduce we introduce JavaScript as the programming language of the web. Right? It's the language that runs on browsers and natively run JavaScript. And it has evolved over time quite a bit, right? From just an immature language, functional programming language, pseudo object-oriented, fairly complex, mature language that has borrowed many ideas from many other languages, and that is now a much more mature and serious language, especially with TypeScript. We're not going to be using TypeScript in this course, although you're welcome to explore TypeScript by changing the content to include TypeScript, but not quite yet. But if you explore TypeScript for your project, that's great. It's just JavaScript, but adding types, right? Where you can do build time testing and debugging. Whereas JavaScript is all runtime, so any debugging that you do is mostly on runtime. Whereas TypeScript allows you to catch errors much earlier. What object orientation does, very allows you to make sure that it's passing the right time, all data typing and whatnot. So we'll take a look at JavaScript, just raw JavaScript, and we'll introduce the latest version of script ES6, and all the syntax that is used that makes the language much more terse, much more compact, fairly easier to read. And we'll show you, we'll talk about when to use one version versus another. And for instance, arrow functions are great. They have great use for this keyword and whatnot. But there are cases that you still want to use just the old functional syntax. So we'll show you, one or the other, and see why still the older syntax is still very popular in industry. So yeah, so we'll spend some time using JavaScript running on the browser. Right, so all this is browser side, all this is front end, the first half of the semester. We'll then build on that. Oh, I'm sorry. We've also introduced jQuery. So jQuery is that it's very, very thin veneer on top of JavaScript that's virtualized the browser. There was, during the late 90s, and there was still today, a war between the various companies that provided browsers, Safaris and Chromes and Firefoxes and all these things, a lot of competition between Microsoft and Google and Apple and a lot of the browsers kind of splintered and had different versions of the browser, different versions of the language, and this kind of splintered the language quite a bit, which made it really, really hard on us developers to build something and test it and behave the same way across all browsers, for all different languages. But we cannot predict, the person who's going to run their browser. We have no idea what version they're using, right? God forbid they were using IE. So we have to write a program, a JavaScript program to kind of, be able to coexist with any browser. So jQuery kind of fixed that. It said, okay, you don't have to target every single browser version. You can just target a common API, right? So jQuery solved that problem of splintering the language across multiple vendors. And it became very popular. A lot of students put on one end of JavaScript. And but it's up to this point where we'll be learning how JavaScript underneath how it's manipulating, right, the browser, right, and dynamic content, moving content, programmatically changing the field, programmatically font, changing the color, adding content, whatnot, right? So we'll learn to do that. It's very low level, specifically low level. But then we will abandon that and we'll put another thicker version on top. Right? We'll put a very thick version on top of the browser, right? And that's going to be React.js. React.js is a library that virtualizes, so that you don't have to think about what's happening in the right? You think about the front page, components, right? Functions. You don't have to think underneath all this just JavaScript. And kind of like, you might first learn assembly language, right? Right? And then on top of it, you might, C, and then you put ever higher, more abstract languages, right? Up until you get ChatGPT, right? And then you have programming. Anyway, so we're going to be doing React.js, and then we'll have a node on the so here is actually kind of do the same thing we did in JavaScript the prior week. It says, well, here's how you do it low level, JavaScript jQuery. Here's how you do the same thing, but with high level language, using React.js. Right? So we'll learn how to generate content. Yeah. Also, we'll learn about maintaining state. One of the challenges in any language or any infrastructure is maintaining application state, right? As user interact with the application, right? They generate a string of events, right? Click, they drag, they type something, right? They train, right? So it's generating a stream of events, and you have to consume those events. And as you consume those events, it changes the state of your application, right? You might deposit, right? You might withdraw, you transfer them to accounts, and all the balances are changing, right? You have to make sure that the balances of one account is increases if you transfer money, right? So all those states, you have to maintain that state. So where do you maintain it? You maintain it at the front end, you maintain it at the server level, where do you maintain it, right? So that's a very huge challenge. We'll take a look at how to maintain state. Redux is one of the ways, very popular. There are other alternatives that are coming up, particular context. Well, we'll explore the various options. We'll take a look at just component state, application state, and React context API. So those are three different ways to maintain the state across applications. Redux is by far the most powerful, but it's also the most hardest to understand. As a very steep learning curve. Right? It's so that's why this particular assignment, Redux is used to over the word. And that's going to be a very challenging assignment, right? Just so you know, right? That's why over the break, a little bit more, and get it. All right, so once we're done with React and Redux and whatnot, we'll have our first exam. On Monday, we'll have a review, and we'll take a look at older exams, so you know what to expect. They'll look very similar to quizzes. Quizzes are all online, well, on Canvas, or the quizzes are all on Canvas, and so the midterm is just going to be one big quiz, but cumulative quiz, right? So we'll have some questions about HTML, and JavaScript, and React, and Redux. Right? So we'll take a look at older exams from fall and spring last year, so you know what to expect, which is more of the same quizzes. And then on Thursday we'll have the actual quiz. Then we'll go out for a week spring break. When we come back, we'll focus more on the back end, right? On the server, right? So we'll well, I mean, we will have been using a server all this time to host our web application. Our front end has to be hosted somewhere. So what we already have been using server, right? But not programming. So on when we come back from the break, we'll create our own server, right? We'll use Node.js, we'll use Node.js Express to create our first client server application. We'll create controllers, server keys, and use REST to create RESTful web services for organizing our account. Then the week after that, we'll do this Mongo as a non-relational database to store our data permanently. Using some best practices, schemas, models, and data access objects. And then the last assignment week number 12, we'll talk about server-side state management. Right, so we have done state management of the client side on the browser, right, on the front end, but we will introduce state management on the server. This will allow us to log in, be able to register, create an account, right, and say who we are, personal profile, and it will allow multiple users the same application simultaneously, right? Up to this point, running the application that we've been building is for a single person. Me, using my application, my server, my database, yes. But then what we really want to do is create a multi-user, dozens, hundreds, thousands of users using the same application, and the server being able to have thousands of conversations with thousands of users. Okay? So we'll do that. That will be our last assignment and the last topic. So after that, it's all project, right? So that's week 13. Now, I'm not suggesting you should wait until this to start the project. I'm suggesting you start the project maybe right after you come back after spring break, and you'll have enough skills. Once I would say, at the end of this week, you'll have enough skills to get started, right, on building, some of the pages, and even if they're static, right, you can start working on the application part, making it look professional, making it pretty, right? You can start doing that already. So yeah, don't wait till week 13 to get started. Okay? But I know most of you will wait till week 13 to get started, and I will start doing a lot of I'm going to do a lot of live coding all throughout. But this week, starting on week 13, we're exclusively going to start. I'm going to start doing my own prototype project, right? And going over all the requirements of the project, and giving you an example of what I need, what each requirement needs. Right. So if one of the requirements is that you should be able to interact with some third-party API. Okay. And you get to choose what that third-party API be. Yelp, the Best Buy, Barnes and Noble, this still exists. Amazon, or whatever API you choose, right? And you can create, something that shows the favorite teams, the scores of whatever particular sport you might like, and you can navigate through all the statistics of the various teams, right? Or a lot of people like food and recipes. If you want to do that, Yumly has a really cool API that also the FDA has a lot of API about food and their calories and whatnot, right? So you can integrate all of these APIs to put a really cool application of where you ask for a particular dish, it'll give you recipes, pictures of and the steps how to do it, and how many calories each ingredient has. It's up to you what it is you want to build. Right? So the project is really open-ended. I'm going to be building a movie website, right? Like search for a movie, and it'll pull down reviews from IMDb or from Rotten Tomatoes, right? It'll show some poster images, the various actors and the cast and the director, the plot, right? And so it's all open up to that. And you'll be able to review a movie and add your own, how much you hate the movie or how much you love it. And you'll be able to follow other users. Other users will follow you. You can navigate to each other's profile. So that's what I'm going to be building. Right. So starting here, and you can use that after the prototype. I'll be sharing the code for you. You can use that as the beginning of your own project if you want to wait that long. I wouldn't wait that long, but if you want my source code at the beginning. This is very open-ended, so I might be doing a lot of debugging, live debugging. I know folks might find that a waste of time, but I think debugging has a lot of good. There's a lot to learn about debugging things in multi-tiered applications. Is it crashing in the front end or is it crashing in the middle tier? Let's step through the front end JavaScript, and then let's step through the server as the network communication goes from the browser to the server to the database and then back to the server and then back to. I think there's a lot of value in debugging and seeing how why did you know to put breakpoints there and not over there, right? So this will be a lot of open-ended coding. So let's see. So the schedule here is a little funny because especially because when the semester ends, I think the semester ends like the 19th or something, and so that Thursday is the 20th. So we missed that Thursday, so we don't have that Thursday, and that Monday is Patriots Day. So that whole last week, I'm not going to see you. So that's why we do the exam review on week 14. So we'll do that's going to be our last class, that Thursday, unfortunately. So I won't see you Monday because it's Patriots Day, and I won't see you that Thursday, which was the last day of Sunday, day before. But I'll be available online, and I will have graduate course classes because theirs ends the week after. I don't know why they split that. Like the undergrad ends 1 week before the graduate student. So if you want to join the graduate online lessons, you're welcome to join. And I'll be doing most of the same, just more project stuff, right? And just continuing on that. So if you want to join, you're welcome to. The links are on the here on the syllabus, also available on Canvas if you want to join. So yeah, so we're going to review the last class. The exam 2 date has not been announced yet. I'm waiting for the registrars to let me know what the day is, the actual day, but it will be during finals week, right? It won't be in this room. They have to assign me a room. They have to assign me a date. I haven't done that yet. I'll make that available, but it's that week, right? So for the graduate students, they are required to take it the very last day of class. So for them, it would be also around that. Anyway, so the project, to grade the project, and the project is due. Project is due on the April 23rd. Right, project is due Sunday, April 23rd. And the week after that, that Monday, right? That Monday after it's due, we're gonna have demos, right? Online demos. You have to come, not you have to come here physically. We'll schedule demos for all the teams to demo their project, and what the teams are going to do, they're just going to go through the requirements, right? You'll have a checklist that's already available. Go through that checklist. It says, is it does it look pretty, right? Is it responsive, right? And, you size the screen, and I can use it as a very narrow screen, and use it as wide screen. Does it, can you interact with third-party API? So those kind of stuff. You already have a checklist that you're required to submit as part of the project deliverable. They're just going to go with that, over that list with you, right? And they're just going to give you a grade for each requirement. Yes, no, yes, 1 out of 5, 4, 5, 4, 4, 5, 4, over down. So you'll know your grade in that online demo. See if it's available, and you'll choose one of those. Yeah, so also that week we're going to be very, very busy. I mean, any question that you need, help fixing something with the project, you're not going to do that. Very happy. The prior week is they grades are due. Yeah, you see the grade data. Okay. What else? Let's see. All right, so there's 10 assignments. The assignments take up 40% of the overall grade. They are about 7 quizzes or 6 or 7 quizzes. So the quizzes together is 10%. The project, which is going to be working together, right? That's going to be 40% of the grade, and 2 exams each 10%. Okay. So let's see. So for the project, it's a team effort. Okay? And we used to scale the complexity of the project depending on how many team members were. But it would be easier for stuff, right? It's harder. And we have abandoned that. It's very hard to to make it so that it works. The rubric works well for all those various combinations. So we're just gonna leave it the same for everybody. I don't care if you're 5 team member or 1 person, right? It's the same response for everybody. Right? We might go with the lenient on you if it's just your job. Okay. But as a principle, we're not gonna make any difference. Okay. Actually, it might be much harder if our bigger team, right? It's very, very typical, very common that bigger teams have a harder time coordinating and tend to override each other. They can't agree on how things are going to be done. So I would suggest that we keep teams within maybe 2, 3 members, maybe 4, right? But if you want to go that high, and 5 team members, you're welcome. But smaller teams are easy to manage. Also, and I don't want so whatever grade the team gets, that's what they reduce. Right? I don't want to get into drama semester that I don't know, this person has been slacking. I think I've told them, I did all the work. Nobody helped me. Blah blah blah. Choose wisely who your team members are. Okay, and just keep them accountable. If something happens like that, I need to know that really early on. Okay, so that's why I suggested you get started now as quickly as possible. And if you see that something's slacking and you get hold of them, they're being MIA for the last couple of weeks and they're not participating, it's fine to come to me and we'll put maybe that person on a separate team or on their own or whatever. But I need to see that very, very early. I can't, 2 weeks for the project to be demoed and I start hearing these things, and it's too late. I can't do it, right? We have to investigate and see what he said, what you said, it's just a mess. I don't want any of that drama, please. Okay. Also, the assignments are meant for you to work individually. If you showing off, you're welcome to use any source code that I give you, right? And I can provide a lot of source code. A lot of copies from the assignment and put this in there and get it to work, right? But don't go looking for people's repositories. It's fine if you find something on Stack Overflow, right? And if it has something to do with the assignment, right? That's a nice little library that keeps something. That's fine. Right? But if you are copying something, make sure that you don't take credit for it. Right? Don't try to fool people. If you're copying something, it's legitimate. That's fine, right? But if you're not sure, ask. But certainly don't try to see. That's important. Just give the attribution of where you're getting something and how relevant is it to whatever you're doing. Late submission. So I think it's a very simple late submission policy. It's all assignments are due Sunday at midnight. If you need 2 extra hours, 2, 3, 4 extra hours, that's fine. Just keep working and submit it 4 hours later. We're just going to deduct that many points from the final grade, right? So whatever grade you've gotten, if you were 3 hours late, it'll be just 3 points off. Right, so if you need more time, that's fine. Go ahead, take the time, right? But we'll just take off that much time, right? And obviously, if there's if you have an illness, right, or if you have some family issues, or we'll be meeting with you and help you out, as much as we can. So let us know if that's going to happen. I know some of you might be traveling for sports and time for other issues. Let me know. We're anything that's reasonable. We'll work with you, right? Business project. Yeah, just please, for academic integrity. We're all adults, right? So we all know that the work that you're providing should reflect your skills, your effort, right, and yours alone. Obviously, on the project, it's a team effort, right? And for the project, I provide a lot of example code. You're welcome to copy from my code that I provide to you, but no one else's, right? Also, the TAs have been with me for several semesters, so they know projects and assignments from previous semesters. They've graded them. They know what other students have done in previous semesters. So don't go looking for repositories from previous semesters from other students, right? Please. I don't want to get into any of that drama. Unfortunately, there's always one person or one team that gets into drama, and it's there's a lot of crying, and or you're graduating, your family's coming over for graduation, and I don't want to get into that drama. Please. I am required to report
if I just if I have the smallest inkling or doubt that this is that what you're providing is not yours, right? Please don't put me in that position. Yeah. So again, I welcome you to if you have questions and you want me to repeat something, please stop me and we'll go over it again, right? Or we have office hours. We can add more office hours if we need to, or if you need one-on-one, let me know. And I'm totally open to having additional one-on-one time. I'll give you my personal phone number. You can call me, you can text me, and we can set up a time that works for both of us, right? All right. Any questions? Yeah, sometimes maybe a link platform. It's not relevant. It's not the solution to your assignment. It doesn't mean that, right? But it only has hey, I didn't do it. Whatever. It's fine, right? It's not a solution to whatever. But the most important part is that you're not deceived, right? Or kind of pass some material as if it were your own. Yeah. Okay. All right. Pass in the chat. The audio only works from okay. I'll try to be closer to the laptop. Sorry. Okay, so yeah, so this piazza, again, this piazza is being shared amongst 3 different sections, and I will make an effort to tag any messages that are for a specific section, right? So, for instance, I might say something about on Monday not having classes, so I'll make sure that it's tagged as CS45, right? So that my other online classes don't get confused, saying, wait, what? You have no class on Monday? So I'll make an effort to make sure that it's clear if it's a specific message for a specific section, all right? But I'm sure I will fail sometimes. I'm sorry. But yeah, so we're going to be sharing most of the questions that folks are asking here will be relevant to all sections, all right? Most of the, I would say 80% of the assignments are the same. The graduate folks will have additional things that they might ask about their particular part in the assignment that's not relevant to your section, but that will be clearly marked. Okay. Yeah. So please ask them to answer. So that the TAs, there's always going to be 1 or 2 TAs monitoring the piazza, right? So to make sure that we quickly get back to you, even if they don't know the answer, they might just respond, "Hey, I'm looking into it. Just a second. Let me find out that for you," right? And they'll come back with the actual answer, right? You'll have to come to me to ask me, and I'll let you know. GitHub. So all assignments and projects will be submitted through GitHub, right? And so you create GitHub repositories that will host your front-end React.js project, right? This first half of the semester. And then the second half of the semester, you'll have another GitHub repository too. Okay? One that has the front-end code and project, and the other one will have the back-end code and the server. Yes, right. In the first half of the semester, we're only going to be doing one GitHub repository, which will be the React front end, web front end. Okay. When we come back from the break, we'll create a second repository, right, which will host the Node.js server side of the application. Yes. But everything is through GitHub. So all the assignments are going to ask you to submit the same thing. Right? All the assignments are going to ask you submit the GitHub repository, right, for this assignment. Right? And it's the same GitHub repository. You'll have different assignments in different branches. So the first assignment will be in branch A1. The second assignment will be in branch A2. And then A3, A4, A5. Each branch will have its own branch. We'll go over some really, really basic GitHub skills. How are we doing with GitHub? How comfortable do you feel with GitHub? Let's see that quite a few. Awesome, great. Some really basic stuff, right? Just creating branches for each one of the assignments. Also, the Netlify will allow us to deploy different branches to different URLs. Right? So this will allow you, the TAs, to be able to, grade assignment 3 while you're still working on assignment 4, right? Without, any concern that you're going to overrun. Right? So that's the point of having the repository. You can always go back and you can redo, branch off and whatnot. So it's great. The other thing that we're going to be asking you in the assignment is a link to your application deployed on Netlify or Heroku or AWS or whatever. Right. So those two things, we're going to ask you the same exact things over and over. Right. So yeah. So those are the deliverables for all the assignments. Right. So lots of GitHub this semester. All right. Excellent. Hold on. I think this goes till what? 1:30? Like 1:25? Okay. All right. Okay. Okay. So let's introduce the course. All right. So web development. Any questions so far? Yeah. Yes. Let's see. It's not Thursday. Oops, that's not it. Let's see. Yeah, why did it show dates? So it's on the syllabus is week. Let's see. So it's week 8, and so week 8. So week 8 is exam. So on Monday we'll have a review. Right. That's Monday, February 27th, and then that following Thursday, right, we'll have the exam right here in live. So that Thursday. So it must be the 30th. Oh, wait, no, the 1st, the 2nd. Why is this doesn't have dates? Well, I might have not copied correctly. Dates. So week 8. Yeah. Okay. So March 7th. So that Thursday. Also, yeah. So you by university policy, you are required to be here, present, in class. Me personally, I don't mind if you're online remotely. I do remote courses all the time, and the course is designed to be either for in person or for remote. But I've been asked to enforce the fact that you have to be present here, right, for the in class in person. And if you are sick, obviously, please stay home. You're welcome to follow along in Zoom or recorded videos. But otherwise, you are expected to be here. Right? And I think there's a couple of folks seated over there. So next time around, try to sit more in the center to give other folks space to sit on the sides, right? And on the exams, I would usually ask you to be staggered, but there's not enough space to stagger anybody. All right, so let's take a look at the. All right, so web development. So what is web development? So first of all, what is the web, right? And that obviously asks, well, what is the internet? So the web is just a software, right, stack that runs on top of the internet, right? And so then the question is, well, what is the internet? So the internet is just us trying to survive World War III. After World War II, we had allies. How is it that we beat the Germans? And we just bombed the heck out of it, right? We just destroyed all communications, roads, telecommunications, phones, everything, right? So there was no way for them to keep supporting. And so folks were saying, well, we want that to happen to us. What can we do to create a communication infrastructure that would make it very highly redundant, that there's no one single point of failure, and that there's always one way to communicate across multiple points of communication. So the defense, the War Department, before it was the Defense Department, was tasked to investigate what kind of technology we could bring to that. And so folks started looking at creating a network communication between computers. So there was a lot of iterations, different versions of the internet, and it was first used internally by the Defense Department, but slowly was opened up for to academic universities and research labs. One particular research lab at CERN, and Tim Berners-Lee in the late 80s, all by himself, invented the World Wide Web. Okay? And he was just trying to just share his research results with some of his research buddies, right? And says, okay, well, it was everything was there already, right? Everything was already invented, that the infrastructure, the technology stack was already there. So folks already knew how to transfer data between computers. Already people knew how to format certain text into something pretty, right? They already know how to do that. It was just very cumbersome, right? You have to use one program to transfer, another program to view, another program to compile the content into something viewable, which is very, very cumbersome. What he did was, he wrapped everything nicely into a set of technology, the server that would be able to host the content. He chose a very easy to read text formatting language, HTML, for formatting the content that anybody could write with any regular text editor. And he wrote touch these documents, right, and automatically compile the content and render it in a nicely formatted, user-readable format, right? And also he was targeting obviously a particular use case where you had going over research papers, and a lot of those, when you write research papers, it's typical that you reference other research papers, right? So he wants to have a really easy way that as you're reading your research paper and you reference another research paper, you click on a hyperlink and it goes and downloads that other research paper, right? So you can easily go between. And so inadvertently, right, he just created something so trivial, right, that just took the society by storm, right? So it first exploded here at CERN, and quickly it became the standard way that universities and and research folks all over different academia started sharing content, right? And then the rest is history, right? And so the content just exploded, right? Folks, the bar was so low for somebody to write something and make it out, put it out there on servers, that it just exploded exponentially. So these are some of the technologies that he invented, by the browser and URLs, for universally being able to identify where all these documents existed, right, all over the internet, right, on multiple servers all over the world, right, and just having simple text that you can click and automatically go fetch those documents and render them. But very, very simple stuff. Some really interesting milestones, internet in the 60s, then the client server architecture in the 1970s. This is an architecture that is still widely used today, very relevant today, but it was invented in the 70s, right? So it's technology that still stick with us. And where computers were giving a specific role, right, when they connected. One had the role of hosting some kind of resource, right, data, images, documents, all sorts of stuff, right? And then you have another computers that were the clients, right, that were asking the server to do something for them, right? It was much more relevant back then when servers were huge machines, right, in these huge rooms that only very specialized folks were allowed to touch the servers, right? And then everybody else had these really dumb terminals, that they were able to remotely communicate with the server, right? And the clients, machines were very dumb, very low powered, and everything was a request, right? So everything was computed at the server. You would send the request, the server would compute something, and then you would see the results running on the client. So it was very relevant back then. Still, today the architecture is widely used, but the difference between the clients and servers today is not as pronounced as it was back then. Another revolution in the 1980s, the personal computer. So all these dumb terminals now all of a sudden became much more powerful machines, and we can and cheap enough that everybody can purchase one and take home and have it in their own desktop. So that revolutionized software development, software engineering. Before, all software was run on the server, and dumb clients asked the server to do things you would see. Now with personal computers, they were powerful enough to actually run pieces of software on your desktop, right? And now you have all these CDs and all these disks and whatnot, how you distribute all the software for the clients who are using it, right? So as opposed to having a centralized server where you have only one piece of software that everybody uses, which is funny because that's kind of where we're going back, right? It used to be when you have the centralized server, the same piece of software that everybody used amongst dumb clients. Then it became the personal computer where software ran on your desktop as opposed to a centralized server. We're kind of going backwards to the initial, back when in the 1970s, where now you have these powerful servers, the Googles and AWSs of the world, where they're running all the software in these servers, and now all software is distributed as just some kind of web application, right? A slide, right? Instead of having PowerPoint running on your desktop, this is Google Slides running a little bit here and a little bit on the server, right? So it's funny how you see the technology kind of go backwards and forwards. The pendulum goes one way and the other, right? It's very interesting. So then obviously the World Wide Web revolution, web applications. So in the 2000s is when we first folks start looking at these various technologies of servers and browsers and JavaScripts and databases as kind of like a stack, right? A multi-tiered set of technologies that could work together, right, to build an entire application, right? As opposed to an application being distributed on a CD, and that's the whole application. Now the application is kind of spread out over multiple tiers, right? Where you have some stuff running on a database, some stuff running on the server, some stuff running in your browser on your machine. So it was first recognized as a kind of like a platform where we can actually build entire applications. And the first iteration was to do most of the computation on the server side, right? All the rendering, all the front end stuff, even the front end stuff would run on the server, and then you would just see dynamic content generated on the server. Today, it has moved over away from that, although we're kind of going backwards to that. So you see the pendulum going backwards. So then obviously the mobile computing revolution, big data, huge amounts of data being collected from folks, right? Data mining. So what's next? Neuralink will be connected to, or maybe the future is ChatGPT. Right, just say everything in English or any language. I was asking the other day how to, I asked ChatGPT to create a small little server that hosts a RESTful API that it wrote all the APIs for me. Even added comments in English, very nicely. And it says, well, now talk to me in German. I rewrote the whole thing in German. And it says, okay, now in Italian. And it's, everything in Italian, so it's nice and scary times. Server framing. So these are some milestones on what's happening. But in tandem, servers are evolving over time. In the 90s, early 90s, and folks started looking at some of the limitations of HTML. Right up that point, right? The way Tim Berners-Lee had thought about it was, well, have a research paper. It's not going to change over time, right? These are my tables, these are my results, right? My introduction, my conclusion. It's a research paper. It doesn't change over time, right? But once this became so available to all the folks, people started looking at what limitations were there, right? Especially when it got to some entrepreneurs, companies, private companies, saying, how can I make money? And so they started thinking about products. How can we create a product? So one of the limitations was that HTML was static. And so look, how can we make this dynamic? One of the first things said is that, okay, well, when the browser asks for a document, how about, right, instead of returning a static file, right, with HTML content, how about instead we run a program on the server, right? We programmatically calculate what that output should be, right? And then spit out that HTML, right? It's calculated. It's being static HTML, right? Now it's calculated. Goes back to the browser. And it says, well, what do you get for? Well, for instance, a few things that might change over time, right? Maybe like a weather application, right? But it changes over time, right? It would be nice that if I refresh the screen, I don't get the same weather, right? It's sunny, it's snowing, whatnot, right? So the application can programmatically look at the weather, right, and generate the correct images and description of what to expect in the next 5 hours, right? So that needs to be calculated in programmatic. So the first ways to do that was a common gateway interface to any number of languages across the and this idea just took off like crazy, right? There were all kinds of languages, and everyone was jumping on this. All the different powerful corporations jumped on this idea. PHP became very, very popular as the standard language on how to generate this dynamic content on the server, right? Java was the first one to come up with a very standard set of best practices and things. And before that, it was kind of all over the place. Everyone was doing whatever they wanted. It was just a chaos, right? Everyone was doing whatever. It was nightmare. So Java was the first attempt at kind of like structuring on how is it that you should do this, what are the best practices, what not to do. They started using a lot of best design patterns, right? The front controller, the model view controller, right? All those things came up from this first iteration. .NET copied them and improved on that idea. The year after that, and there was a plethora of great things happening in server side, like Ruby, Django, and then even Node.js and JavaScript. This is where we're going to be. Flash, tons of server-side solutions. How is it that you can dynamically compute content and pump it out to the browser, right? So in tandem, in parallel to this, there are also things happening on the browser side, right? So all this is happening on the server. Servers calculating HTML dynamically, but also on the browser side, folks will say, oh, well, instead of having this content being programmatically calculated on the server, why don't we calculate directly in the browser? Can the browser do things dynamically, right? At first, it was very, very limited things that you could do on the browser, right? You could do maybe validate a form, right? Like if I ask you for your date of birth, right? I want to make sure you're giving me numbers for month and year, right? Or that you're not giving me a date that is in the past, right? So all those kind of validation could be done on the browser, right? The browser could then programmatically check the form and submit, right? Valid form and not send anything to the server unless the data was valid. Yes. So all that could be done on the browser. So JavaScript was first used for that. Also, lots and lots of cat videos. And so, so all that was happening in Netscape. And so, how can we dynamically do things in the front end? So it was a huge technology gap of what we could accomplish in the browser, and that's where Adobe Flash, took that hole and filled it. With Adobe Flash. And so we had like a decade of Adobe games. But it was, I know my children, played tons and tons of these games, and it dominated things for quite a bit, for a whole decade, right? And so what they did was, okay, well, you can program in this entirely new language, right? it's going to be downloaded by the browser, and the browser using a plugin, right, would run this entirely new application. Meanwhile, the folks were looking for, so this was kind of, you needed a plugin. You had to download a particular plugin, for the browser to work, right? So they were looking for ways that you could need a plugin, right? So folks were still exploring JavaScript. So Dojo was one of the first pure JavaScript solutions that run on the browser. And so all these iterations of JavaScript solutions were building on a language that was very immature. The JavaScript was very, very immature, right? And they were looking for, creating, trying to copy some really good ideas that were happening on the more mature languages, C# and Java, trying to fit in, all these things into very poor language, JavaScript. Obviously, lots of other really cool libraries. Angular from Google was the very first, serious, attempt at creating a framework where you could build serious applications on the browser, right? They copied tons of best practices from the server side, inversion of control, services, cache, singleton. So they copied a lot of best practices that were happening on more mature frameworks, and they built this framework. Unfortunately, they made a huge mistake around with the second version of Angular 2. They shot themselves in the foot, and the next version of Angular was not backwards compatible with the previous version. So companies kind of abandoned the ship, abandoned the solution. They said, wait a minute, I have to rewrite all my code. Anything that I wrote in version 1 is not compatible with version 2. So all the investment that I had done building all this for the old framework is not going to be fully compatible. What the heck? So they started exploring other options, right? And Facebook React.js is there to welcome. And so a lot of folks companies started saying, hey, heck, if I'm going to rebuild something, why not explore what other options are? React.js is where React.js was from. And companies started using React.js to build something. It also has very shallow learning. React.js. Very, very hard to get started in Angular. Angular kind of takes over the entire framework. It's very, very opinionated, whereas React.js is very not opinionated. Whatever you want. Do this way, you do that way. Anyway, tons of other things happening. There's tons of new things coming up that are now certainly as exciting. React.js are definitely worth taking a look at. Definitely Vue.js. If you want to explore that on the project, that would be an awesome alternative to explore Vue.js. Anyway, so this is the architecture of what we're going to be building this month, right? We're going to be focusing most of our effort here, the first half of this month, right? Implementing an application that runs on a browser, on a client. Right? Now, this client could be anything. We're going to be spending it. We're going to be doing just browsers, but this could be a game, could be a desktop application, but we're going to be doing browsers, and we're going to be using HTML, CSS, JavaScript, React, no Angular, no Vue. In the second half of this semester, we're going to be spending the server, building a server using Node.js. And in prior iterations of this course, we used to use Java, and also for the database, we're going to be using Node.js. On prior iterations of this course, we use MySQL. But for the project, if you want to use any other combinations. So this is just a little bit of a diagram, just documenting how the rendering of the content has evolved over time, right? In the 2000s, well, in the late 90s up until the mid 2000s, before 2010, right before Angular, right? Right before Angular, this was the architecture, right? As we go to the website, right? That website would post either static content or dynamic content implemented as PHP, JSP, PHP, or Python, right? And it would be requested to the server. It would run on the server, right? The server would dynamically generate HTML, and this would be sent over to the browser. The browser didn't know that the content was dynamic. As far as the browser was concerned, the content was static, right? It was dynamically generated by the server, right? But the browser just had a static ASCII file, right? An HTML file. Yes, and it rendered it for the user. Today, we're getting away from that. Well, actually, we're kind of going back to this, but we'll have more on that. Today is slightly different, right? And tonight, in the architecture is slightly different. You go to the as request a page, and that web page is the server finds that page, but usually that page also references JavaScript. Okay? Both of them are downloaded to the browser, and then that JavaScript doesn't run on the server; it runs on the client. It runs in your browser. And in your browser, right, it dynamically generates static content. There might be some dynamic stuff that it needs to render as well, right? Maybe quizzes, right? Or you go fetch from assignment, what grades it has, right? So it doesn't have that. It doesn't have that data. So the JavaScript makes another request. The server has that. And the data in the server either goes to the database or calculates that data on the server, and it responds with data, some JSON object or array or some data structure. But then the JavaScript dynamically renders the rows or lists, tables, dynamically renders them in your browser. Yes, right. Today you see that there's kind of like a mishmash of both, a little bit of both being used for this is still used for very static, very performant content. Like for instance, the first couple of pages, right, that you want to pump out to your clients, that needs to render really, really quick. Right? You don't want to render a title and then a whole bunch of spinners, right? Because the JavaScript goes back to the server asking for data, right? And the spinners are waiting for the server for data to come back, and then they get rendered, right? So you want to generate content that comes to the user really, really quick, to catch their eye, some really nice video and some bright colors, so that users don't just navigate away, right? So they're here to stay. So you grab their attention as quickly as possible. So this is still used for highly performant, pre-compiled content, right? But then as they navigate to the dynamic portion, right, it's more of this architecture, right, where they dynamically go fetch more data, right, as you iterate, or maybe as they scroll, right, you go fetch more data, you fill in the content as they go. The first example of this application that I saw anyway was Google Maps. And I don't know if anybody remember MapQuest. Anybody remember MapQuest? So MapQuest was the precursor to Google Maps, right? But it was built using this technology. Right? It did everything Google Maps does now, right? And so you would see the map, but if you wanted to pan left or pan right, you had to press a button, right? Pan right, pan right, pan right, up, left, 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 left. And every time you click the button, this would be a new browser request to the server. The server would recalculate what image and render, right? And then it would be sent back to the server, the browser to render. Okay, it was a very jarring interaction. Right, the whole page had to be re-rendered brand new. Yeah, it was entirely different when I first played with Google Maps when it first came out. You can grab the map, right, and just kind of jiggle around, right, drag it, and just look it, right, and then using this technology, where most of the content is static, but then the dynamic portion is just multiple queries that go out to the server, right, for to fill in the empty space of whatever you're dragging around, right, and to go fetch all those images to fill in the empty spaces as you drag this content, right. the user interface, right, and the interaction is entirely different. Right, one is very jarring, whereas the other is very smooth, right? And so modern technology applications are mostly using this strategy, right? As you scroll through tweets or Facebook posts or whatever, right? As you scroll, it's fetching more content to fill in, right? All that content that you have to emphasize, right? Using this. So this is what we're spending most of our time in this right? Okay, so I do want to go over this fully. We'll come back to this. Okay, so the first assignment is asking you to set up a development environment, right? And the first install an integrated IDE, integrated development environment. I'm using IntelliJ. You're welcome to use Visual Studio Code or some other. But all my examples that I'm going to be using here is IntelliJ, right? And I use the ultimate version, which has full support of web applications, Node.js, JavaScript, TypeScript, and all that. So if you have a non-ultimate version and you intend to use IntelliJ, I would strongly encourage you to download the ultimate. It is free for students, right? If you register using your NEU EDU email, so yeah, you should install that if you're using IntelliJ. Yes, this is the architecture that we're using for the server. So for the server, we're going to be using Node.js. There's tons of server options. We're going to be using Node.js. So please download Node.js. You can download and install it in previous semesters. Please reinstall it. The latest 18 is the latest 19. Yeah. So install that. And once you install that, it's going to install several executables, right? Of which we are interested in 4 things. Node, right, is the executable that allows you to. So what Node is just a framework that allows you to execute JavaScript on your desktop. Right? JavaScript, when everybody thinks about JavaScript, is that's the language that gets executed on browsers. Yes, and you'd be, mostly right. A few decades ago, where that's true. JavaScript was the language that executed on browsers. Yes, that's how Netscape implemented it way back when. Yes, but today, since 2009, right, you can also execute JavaScript outside of the browser. Right? And the only way you can do that is using Node. Right? Node.js is a framework that allows you to execute JavaScript on the desktop. That's all it is. That is all it is. Right? So please install Node.js. You need that at least. Once you have Node.js, you'll have several executables. One is Node. Node allows you to execute JavaScript application. You say Node hello.js. Right? It'll execute your hello.js script, right, in your desktop. You'll also have NPM. NPM is a Node package manager, allows you to install packages, libraries, right? There's a whole. That's true for most languages. Right? If you look at C# or Java or Python, on their own, the languages are not that interesting. What's really interesting is all the libraries and community that has been built around that language or that framework, right? And so. Same thing, JavaScript and Node.js are not that interesting, but there's a huge community that has created tons and tons of really good libraries. And the way you install those libraries is using NPM, right? So Node package manager allows you to install packages. The other executable that we're going to be using is npx. So NPM allows you to install libraries and to execute these libraries without having to install them. Okay, so once you install Node, create a couple of folders. So for instance, in your home directory, create maybe a folder called 2023 for the semester, then maybe a spring, a Spring directory in there, and then maybe a web dev directory in there. Okay, so let me do that. Okay, so I'm gonna free. Oh, no. All right, so I'll make a directory Spring, and I'll create a directory CS4550. So you'll call it web dev. I'm going to call it CS4550. Okay. So I'm going to go to CS4550. This so that I can have other directories for other sections. So in here, in that directory, we're going to create a React application. We're going to create a React web application, which we're calling React. Okay. So to create it, you're going to say npx create React. So create React app is an application, a project that was created by Facebook. Facebook is one to maintain and React.js, and they're all available online if you visit npm.js.org. So npm.js.org is a live stream. Anyway, it's a repository of open source projects that the various corporations maintain. Oracle, Facebook, Google, they all you. You can also host your really cool library and make it available here, and it could be the next mobile, right? Be working for you. So these repositories are there, and you can search them. Some of the more famous ones that we're going to be using that is Express. Express is used for building HTTP servers. The semester. There's also create React. Huh? There's a TypeScript version. So create React app that's maintained by Facebook, and they have you can look at the repository, you look at their source code. You can install it by either install the library using npm install create React app, or you can just execute it, download it and execute it right away. To do something. So that's what we're doing. We're saying npx create React app, and then the name of the application. And so the name of the application that I'm choosing, is what was the name? Twitter. Twitter React web app. I'll call it CS4550, and this is Spring. Okay, that's going to take a bit, right? So what it's doing, it's downloading a lot of JavaScript, a lot of libraries, and we're going to create a React application that is ready to go. Right? It's already compiled, and we just get started. Right? So it's a hello world, and we're the simplest out of the box implementation of a React app. Okay? It's which is going to be our front end, the front end of our application. Our application is going to contain a front end implemented in React.js and a back end implemented in Node.js. Yes, and Express. Right. The first half of the semester is going to focus only on the React side. Okay. The second half of the semester is going to focus on the server side, on the Node.js part. Yes. And so we're going to just focus on that directly for the next 6-7 weeks. Okay. So while that's going, if we start that, we can start the application by saying npm start. We'll do that in a minute. So it's also asking you to install a Git client. So if you have a Mac, you should already have a Git client. You don't need to do anything. If you have Windows, you can install a Windows Git client, right? But I saw everybody raise their hands. Looks like everybody should be all done. Maybe you might need to update your Git client to the latest version. If you want a UI graphical interface, source tree app is really nice. It gives you a nice graphical interaction with Git if you prefer to do that. Ignore files. Make sure to ignore certain files. Right. So all your projects, whether these are Java, Python, or Node.js, there'll be a lot of libraries that are downloaded from that support your project. Yes, these libraries should never be added to your repository, to your source repository. That's what it's called, source repository. Only source can go into source repository, and not anything compiled, right? Not .classes, no .objects, okay? No jar files, right? No zip files. Okay, so only source code should go into source control. So we'll do it in a minute. We'll add a .git ignore. Probably have one already. And we'll add these two entries. One is node_modules. A node_modules is where Node.js installs all the libraries, right? All the compiled libraries. That's where it puts it. That we don't want it in source control, right? So we're going to add that to git ignore. That idea, that's for those that are using IntelliJ. But if you're using VS Code, there'll be another. I forget what the extension was. There'll be another, IDE related content, right, or configuration that should not make it. Is that done? Okay, it's done. So now we can go. Let's see. So I created the application, and it creates this folder. We can go into that folder, and notice the node_module, right? That's where all the compiled libraries support this project, right? We don't want to add that to source control. Okay. All the source content that is all React based is underscore RC, and we'll play with that a little later in about 3 weeks. We're going to spend most of our time on the public for the first couple of weeks. Right? We'll be learning static HTML, JavaScript, CSS. Right? We're not going to look at React.js for a couple of weeks still. So when we get back to React.js, we're going to SRC. While we do all the static stuff, we're going to go into public. Public contains the it's a very common name for what servers make available publicly to the rest of the world. Right, so anything that you want to be made publicly available to the rest of the world when it runs on a server, you put it under public. Right, any images, any audio, any static text, HTML documents would go under there. Here's our git ignore, right? Notice it package.json. That gives it away that this is a Node project. Right? This is a project implemented using Node.js. Right? Very similar to if you're doing Java, you would see like a POM file, POM.xml file, right? That gives it away. It's a Java project. So each type of project has its own configuration file. For us, all right, so let's open this up. Now to run this project, we can use npm. So npm, remember that's one of the 3 things that are installed when we install Node.js. npm is one of them. It's used for installing library, but it's also used for managing your project. Okay. One of the things that you do is run, right, the project, right, by saying npm start. npm start. So this kicks off it compiles your project and builds it, links it, and then runs the project in a brand new browser. Okay, so this is our hello world simplest, most trivial React.js application. We're going to blow it away and we're going to replace it with our own. All right, so it's running. By running means that this is being hosted by a local server, by a local Node.js server running at localhost. That's a local IP address or a name for a local machine. Otherwise, it can be used as 129.0.0.1 is the equivalent. And listen to port 3000. Port 3000 is a very, very A popular port that are used among Node.js developers and React.js developers, very common. And just like, if you're using Java, it would be, or Tomcat, it would be 8080, right? So it's a very, very popular IP address in port. All right, so let's see. We can close this and open our brand new project and say open. Now we can navigate 2023 in here. So we have Spring, CS40 on that, and there's a brand new project. I'm going to open that up. So we're going to add to our repository. We're just going to add the fact that we do not want our node underscore modules, which is already there, right? So yeah, so whoever created the project already knew that it was a good idea not to include that. Also, but I don't believe this is a repository yet. Let me see. Let me stop this. All right, so we're going to initialize this as a repository. And I think that the assignment walks you through that. Assignment. Yeah, so it walks you through that. Create a remote repository. Committee. Yeah, we have to git init. Let's init that. Do a git init to create the okay. We already had a repository, git repository. And we're going to add everything. I'm just following the instructions here. Oh, we're not going to be able to push just yet because we don't have a repository. So let me create a repository in Git. So let me go to Git. And I'll call the repository the same as my folder. So in Git, I'm going to say new. And I'm sure you are all familiar how to do this. Oh, that's too long. Did it work? Yeah. Well, I'm going to make it public. Please, keep your repositories public so that your TAs are going to be able to visit this. They're going to be in that repository quite a bit. So create a repository. Once you create the repository, you can follow these instructions. Git init, which we did already. We already added everything. We're going to commit our very first commit. We're just going to follow the instructions, which are also in the assignments. We're going to change the branch to main, and we're going to add this to an origin, and we're going to push. We're going to push all our code in here. And let's log in. And once we do that, your source code, pushed everything to the source code. So if we refresh this, we should see now the source code. There it is. So this is the same source code that we had locally in the machine. Yeah? So this is one of the deliverables. And you copy this URL, and you're going to submit that URL. Okay. Second thing is that we'll do on Thursday is we're going to deploy this on Netlify. Okay? So the assignment walks you through that too. The only thing you have to do there and provide this URL. Right? Create this repository, give it your permission, log in, blah, 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 give it permission to log into Git for you, right? And it'll copy all your source code here, and so that you're going to be able to run this, right? Instead of just running here locally. Hello? Maybe? No? Oh, here. Instead of being able to run this only locally here on my machine, we're going to run it on a public machine that is available to the rest of the world so that everybody can see the quick things you're doing. Right? Awesome. Thank you. See you on Thursday. Yes.